Hey everyone, welcome back. Today we're going to study some more quadratics and we're going to look at what's called the standard form. If you've completed the previous video studying quadratic functions, today's lesson will be a lot easier for you. And we're actually going to be doing the lesson as if you had watched it. So if anything is difficult in some of the characteristics of quadratics that I'm mentioning, if it's new for you or difficult, please watch the previous video of studying quadratic functions. So general form. F of x equals ax squared plus bx plus c. We saw a couple of advantages when it's in this form. The parabola opens which way, right? Our a tells us that. Y-intercept is easy to get. You plug in x equals 0, you get c, like that. And you can factor to find x-intercepts. And so here is standard form. F of x equals a times x minus h squared plus k. And this is what we're going to study today. So it has some advantages. One, it tells you the parabola opens which way, looking at our a value. The vertex is easy to get. We're going to practice that in this lesson. Axis of symmetry is easy to get. The range is easy to get. And getting intercepts is not difficult. So let's dive right in. So here we have three functions here, x squared, x plus 1 squared, and x minus 2 squared. And we're going to practice looking at the x component of the vertex. So this is the vertex here. It occurs when x equals 0. This is the vertex here. It occurs at x equals minus 1. And here's the vertex here, which occurs at x equals 2. And so you notice that if you plug in minus 1 into here, this component is 0, which is the minimum, like that. Same thing here. If you plug in 2, right, 2 minus 2 makes this component 0, gives us the minimum, like that. Okay, now what about the y component? So here we have x squared plus 1, x squared minus 2. So we see the vertex, the y value is at 0. Here the vertex, the y value is at 1. Notice that it's a 1 like this. And here the y value is negative 2 for the vertex. Okay, so here's an example here. F of x equals x plus 1 squared plus 2. So this part here being 0 gives us our minimum or maximum. So what do you plug in to make that part 0? Well, you plug in minus 1, right? Negative 1 plus 1 is 0. So the vertex is going to be at negative 1 for the x value. And then when this is 0, what's left is a y value of 2, like that. So you see that? You plug in negative 1 and gives you a y value of 2. And so this is what we have right here. The x value is negative 1 and the y value is 2, graph opening upwards like that. Okay, another example with our graph to help us out. So we have x minus 2 squared minus 1. What do you plug in to make that 0? You plug in 2. And the y value you get when you plug in 2 is negative 1, like that. So 2, negative 1 is our vertex. Okay, so determine the vertex like this. We have G and H. So plug in 4 and you get a value of 2 for the y. So our vertex is 4, 2. Plug in negative 5. This becomes 0, gives negative 3 like that. So that is the vertex of this function. Okay, your turn to practice. Here we are like this. Practice number 1. Determine the vertex for these functions. Go ahead and pause the video and answer that. Okay, we're back. So we have vertex negative 4, negative 1. Here you plug in 3, you get negative 2, so 3, negative 2. Plug in negative 1 and you get negative 7 like that. Plug in 5 and you get 2 like that, so vertex 5, 2. And so this is our standard form. A times x minus h squared plus k. So we're going to look at some a values. So here we have a value is 1, so we have x squared like that. 2x squared makes it narrower like that. And then we have here a half x squared makes it wider. So we notice that in all three, a is greater than 0, and so they all open upwards. And then from there, we can say, okay, well, vertex is a minimum. So if ever a is greater than 0, the vertex is going to be a minimum. You notice they're all minimums. Okay, let's see if a is negative. We have negative 1, so this is negative x squared like that. Minus 2x squared makes it narrower like that. Negative a half x squared, it's open downward but wider like that. So a less than 0 opens downward. And if it opens downward, that means the vertex is a maximum. So you see that in common? All the vertex are maximums. So now without the graph, we're going to look at just the function itself. Can we get the characteristics here of opens which way, intercepts, vertex, axis of symmetry, domain, range without a graph? We're going to get it from the functions itself. And this is where watching the previous video of studying quadratic equations will come in very handy. Okay, so this is examples, so I'm going to do them and then you have some practice problems afterwards. So f of x, x minus 2 squared minus 1. So first a is greater than 0, so it opens upward. Y-intercepts, you get that when x is 0, so we plug in x equals 0 and we get 3. So our y-intercept is at y equals 3. X-intercept, this occurs when y equals 0. So we have our function equals 0 like that. And then we isolate x. So we're going to go plus 1 to both sides like this. Square root both sides. So we get x minus 2 equals plus or minus root 1, which gives 1. So x minus 2 is equal to plus or minus 1. So we have two options. We have x minus 2 equals 1 or x minus 2 equals negative 1. Isolate for x, we get 3. Isolate for x, we get 1. So we get two intercepts in this case. X-intercept is 1 and 3. So our vertex, 2 minus 1, right? We see that. You plug in 2, what's left is minus 1 like that. So that's our vertex. We notice a is greater than 0, so this vertex is going to be a minimum. The axis of symmetry, this occurs at the vertex, as we saw in our previous video. So that occurs at x equals 2. Domain, we can plug in any x into our standard form. It doesn't matter. So a domain is all real numbers. And because we know the range is, because we know the vertex is a minimum, how it goes like this, the range is from -1, where the vertex is, and higher, like that, right? We have our vertex in the center, and the range is greater, like that. So y is greater or equal to -1. Okay, 2. Here's our function like that. A is less than 0. A is -1 in this case, so it opens downward. Y-intercepts. So we have x equals 0. Plug in x equals 0, and we get y equals -13. And so that is our y-intercept. X-intercept. This occurs when y equals 0. So our function equal to 0, plus 4 to both sides, divide by -1 on both sides. So we have a positive equal negative. We can't square root a negative. So there's no solution to this. Therefore, there are no x-intercepts. Vertex, -3 and -4, right? Plug in -3, we get -4 like that. A is less than 0, so the vertex is a maximum. Axis of symmetry occurs at the vertex, so -3, x equals -3 like that. Domain, all real numbers, and range, y less or equal to -4 because the vertex is a maximum, right? It goes up like this, there's a maximum, so it's everything below that vertex, and in that case it's -4, like that. Okay, 3. H of x equals 1/3 times x minus 4 squared minus 3. So a is greater than 0, so it opens upwards. Y-intercept, this occurs when x equals 0. So we plug in x equals 0, do the math, and we get 7/3, like that. Okay, so therefore our y-intercept is y equals 7/3. X-intercept, this occurs when y equals 0. So we have our function equals 0. Plus 3 to both sides, times 3 to both sides, square root both sides. So you get x minus 4 equals plus or minus 3. So if it's plus 3, we get x equals 7. If it's minus 3, we get x equals 1. And so our two x-intercepts are 1 and 7. Right, looking at our function here, we see the vertex occurs at 4, -3, like that. So that's our vertex as such. We know a is greater than 0, so this vertex is a minimum. The axis of symmetry is at x equals 4. Domain all real numbers, and since the vertex is a minimum, y greater or equal to -3 is our range. Okay, time for you guys to do some practice. Same question, but different functions. So you're going to determine the following: opens which way, intercepts, vertex, axis of symmetry, domain, range, and here are our 3 functions like that. I highly recommend that you go ahead and pause the video and answer that for yourselves. Okay, we're back. So first function here, a is greater than 0, opens upward. Y-intercept occurs when x equals 0. Plug that in and we get y-intercept of y equals 0. X-intercept, this occurs when y equals 0. So we have our function equals 0, plus 9 to both sides, square root to both sides, and so we get x minus 3 equals 3, or x minus 3 equals -3, which gives 6 or 0. So the x-intercepts are x equals 0 and x equals 6. Vertex 3, -9. We notice that a is greater than 0, so our vertex here is a minimum. Axis of symmetry at x equals 3. Domain all real numbers, and the range greater or equal to -9. Right? So at our vertex, and since it's a minimum, it's greater or equal to -9. Okay, 2. -2 times x plus 2 squared plus 2. A is less than 0, so it opens downward. Y-intercept occurs when x equals 0. Plug that in, and we get y equals -6. X-intercepts occurs when y equals 0, so our function equals 0. Minus 2 to both sides. Divide by -2 to both sides, and square root both sides like that. So we get x plus 2 equals plus or minus 1. X plus 2 equals 1 gives x minus 1. X plus 2 equals -1 gives x equals -3. And so those are the 2 x-intercepts, -1 and -3. Vertex is -2, 2. A is less than 0, so the vertex is a maximum. Axis of symmetry, x equals -2. Domain all real numbers, range y less or equal to 2, because the vertex is a maximum. Okay, last one, 3. H of x is 1/4 times x minus 5 squared plus 2. A is greater than 0, so it opens upward. Y-intercept, this occurs when x equals 0. So we plug in x equals 0, and we get 33/4 as our y-intercept. Okay, next, x-intercept occurs at y equals 0. So we have our function equals 0. We go -2 to both sides and then times 4 to both sides, and this gives us x minus 5 squared equals -8. We cannot square root a negative value, so there's no real solution, therefore no x-intercepts. The vertex is at 5, 2. A is greater than 0, so the vertex is a minimum. Axis of symmetry at x equals 5. Domain all real numbers, and range is greater or equal to 2. And that's it. It's that easy. I'll see you guys in the next video.